Here, radiation is emitted when an electron in hydrogen atom de-excite from level 3 to level 2. This electron falls on a metal to release electrons, photoelectrons. These electrons are entering a magnetic field. Electrons revolve in circular path. Magnetic field value is given. The radius of the largest circular path is 10 millimeters. We need to calculate the work function of the metal. This is the level 3, level 2, n equal to 3 and n equal to 2. The energy values based on hydrogen atom. En is minus 13.6 electron volt by n square. So E3 will be 13.6 by 9, 1.51 electron volt negative. E2 will be minus 13.6 electron volt by 4, minus 3.4 electron volt. So if this electron de-excite and release one photon, the energy of the photon can be minus 1.51 minus 3.4. So it comes 3.4 minus 1.1 ultimately. So if you subtract that, 3.4 minus 1.51 is 1.89 electron volt. Now they're asking the work function. So we have for photoelectric emission, Ke max is energy of the incident light, which is h nu minus the work function. So from this you can find work function as energy of incident light minus Ke max. So energy of incident light we have, that is what, 1.89 electron volt. So if you know the Ke max, we can find the work function. They told these electrons entering magnetic field revolve in circular path, maximum radius 10 millimeter. So in moving charges and magnetism, we have charged particles revolving in circular path. The kinetic energy of the charged particle is half mv square. V you can find by equating the centripetal force and magnetic force. QVB equal to mv square by r. So substituting that, you already have a formula, Q square B square R square by 2m for the kinetic energy. So here Q is the charge of the electron, we know. B magnetic field is given. R is the radius. When R is maximum, K will be maximum. M is the mass of the electron. So we substitute that values, 1.6 into 10 raised to minus 19 charge of the electron square. 3 into 10 raised to minus 4 square Tesla magnetic field. So 10 millimeter means 10 into 10 raised to minus 3, which is 10 raised to minus 2. By 2 times mass of the electron is 9.1 into 10 raised to minus 31. That value is in joules. To convert into electron volt, 1.6 into 10 raised to minus 19. We can cancel 1.6 into 10 raised to minus 9. So calculations will give you an answer of 0.79 electron volt. The values all are mentioned here, the radius, charge, and the mass in the magnetic field. Now, once you get the Ke, this is a Ke max because R is max. You can substitute that back here. So work function is energy of the incident light minus Ke max. That is 1.89 minus 0.79. This is 1.1 electron volt. That's a final answer. This value is 1.51.